Hello there, algebra kids. I just want to say I'm so proud of you. You've made it to, this is the last lesson. You have one more assignment after this, a little review assignment. But I'm just so pleased for each one of you. I know this has not been easy. It's been a new challenge for each one of us, myself included. So I hope you feel a sense of satisfaction. Okay, you know, at the beginning of the year I talked about how success is a direct result of knowing you did your best to be the best that you could become. And I hope you all feel that. I hope you felt like, hey, I put forth a good effort. I did the best that I could to become the best that I could. And only you can be the judge of that. And only you can judge yourself saying, you know what, I could have done better, and I'm going to do better next year. Or I'm going to do better this summer with whatever I'm working on. Okay, it doesn't have to be math. It can be whatever you're working on. That impact that you have on those people around you is what's going to be important. Okay, so always put forth your best effort. Always look to add value and to encourage and help other people around you, and then we're all going to get a lot farther in life and have a good time doing it as well. So this last lesson is not in big ideas. This is again a Google sheet that you need to make a copy of into your own drive and then share it back with me once you have your answers. It's titled "The Composition of Functions." A composition is when you compose something, you make it. And so that leads me to one of my common math jokes is, how come when you go to the tomb of Mozart, you hear Mozart's music, but it's being played backwards? Okay, so if you go to the tomb of Mozart, you hear his music, but it's being played backwards. And the reason it's being played backwards is because Mozart is decomposing. Yeah, you're welcome. Okay, so I'll find out. Email me your most annoying face that you make when you hear that joke, and I'll get a kick out of that, and I'll know who actually watched this video. Okay, so functions composed, created with other functions. So first of all, review, a function is written f of x. So remember, f is the name of the function, x is the variable you're working with. So the function of x, f of x, is 2 times x plus 3. So this is the function that we're doing on x. So if they want us to evaluate f of 5, let's read f of 5, the 5 replaced the x in the parentheses. So you notice we had f of x and then f of 5. So instead of an x there, we have a 5 there. So we replace the x in the parentheses. So we're also going to replace the other x that's in the rule with a 5. So if f of x equals 2x plus 3, then f of 5 is 2 times 5 plus 3. So notice whatever was in this parenthesis gets filled into that part right there. Then we evaluate this. 2 times 5 plus 3 is 13. That would be your answer. So if we would want f of negative 8, that would be 2 times negative 8 plus 3. Whatever replaced the x goes in this other spot as well. So negative 16 plus 3, that would just be negative 13. Okay? So into the compositions. And I would pause this and maybe write some of this down. That way you have some notes. Again, practice writing. It's going to help you in the long term, remembering what to do here. But we're going to have two functions. F of x is 2x plus 3. We'll keep the same one there. G of x is going to be 5x. So 5 times x. And composition, think of functions inside a function. So this open circle right here, that is an open circle. It's not a dot. And that means composed of. And there are a lot of applications of this. We're just going to talk about how to evaluate some of these things. But that means composed of. So it is a new operator for you. Operators are like plus, minus, multiply, divide. This is a new one. This is not a multiplication sign. It's an open circle, but it's tiny. So f composed of g of x. So f composed of g of x is how that's read. Or f of g of x. You can just say f of g of x. So what it means is f of g of x. So f of g of x. The one that's written second is going to go inside the first one. The second function goes inside the first one. So we have to think right now, just like what we did up here. Whatever replaced the x, in this case the negative 8, or earlier the 5, gets substituted into the function f. So what is g of x? Well, g of x is 5x. So if one thing equals another, we can replace it for each other. So g of x is 5x. So this is f of 5x, because g of x is 5x. So we're going to take the function f, and we're going to replace where the variable is, right there, with whatever's inside the parentheses. So we have the 2 from the function, 2. Now here comes the variable, so I'm going to do a substitution, 5x, and then plus 3. So what we did earlier is we replaced that x with a 5 or a negative 8. In this case, we're replacing it with whatever the g function equals, which is 5x. So 2 times 5x is 10x. 10x plus 3 gets left just like that. That would be your answer. So f of g of x is 10x plus 3. Okay, and I love, it'd be great, not going to definitely require it, but it'd be great if you would send me a picture of your work with this, just so I know that you're doing it the right way. And if you have any questions with it, I can answer that as well. Okay, g of f of x. So notice I turned it around. Sometimes I call these the fog and goff questions, not golf, goff. So fog, F-O-G, looks like F-O-G, G-O-F. So g of f of x. So this is g of f of x. So now the f function is going inside the g function. So, okay, so g of f of x. Well, what is f of x? F of x is 2x plus 3. So g of 2x plus 3. So in the g function, I'm going to take the variable out and replace it with whatever the f function is. So that's 5 times 2x plus 3. So distribute, that'd be 10x plus 15. Okay? So that would be your answer. That's what your final answer is there. G of x. You're composing a function within itself. Okay? This is kind of like inbreeding. Okay? It is allowed here in this part of math. So this is g of x. So this would be g of, well, g of x, the inside is 5x, so g of 5x. So this would be 5 times itself, 5x. And we get 25x. Okay. That would be it. F of x. This would be f of x. That is f of 2x plus 3. So we're going to take 2x plus 3 and stick that expression back where the x is. So that'd be 2 times 2x plus 3 plus 3. Need that other plus 3 at the end. 2x plus 3. So that is 4x plus 6 plus 3. So we'd get 4x plus 9. Okay, those are your answers. When we get to the numbers, this should be easier. We don't have the expressions to work with. So let's break this down. G of f of 10. G of f of 10. Well, what is f of 10? We can evaluate that. F of 10 is 2 times 10 plus 3, which is 23. Take that and plug it back in. So what is g of 23? Well, that's 5 times 23, which would be 115. Okay. So you can take the 10, you plug it into the f, and then that answer goes into the g. 10 goes into the f, that answer goes into the g. Now notice we also came up with a formula for g of f. So if I go back up here, g of f of x, I have this formula here. Look what happens when I plug the 10 into this one right here. I take 10 times 10 plus 15. Well, that's 100 plus 15. I get the same answer, which is what should happen. Okay, so you have two ways to do this. You can either take the original formula from up here and just plug the number into it and get your answer. I think that's a little easier if you have this already. Or you take the 10, plug it into the first one as you work your way from right to left in this case, plug 10 into f, take that answer, plug into the g. And you can do a composition with 3 functions. Okay, there's your extra credit question. Okay, come up with a composition of 3 functions and work it out. So say f of x is this, g of x is this, h of x is this. Find f composed of g composed of h of x. Okay, so f of, last one, f of negative 4. So I'm going to take this first one. What is f of negative 4? Well, that would be 2 times negative 4 plus 3. That'd be negative 8 plus 3, so that's negative 5. I'm going to take this answer and plug it into the first one. So what's f of negative 5? Well, that'd be 2 times negative 5 plus 3, which would be negative 7 when we're done. Okay, let's check that. We had an f of f function. It's 4x plus 9. So what is 4 times negative 4 plus 9? Well, that's negative 16 plus 9, and that equals negative 7. So it does check. We did it correctly. So I think you have maybe 12 questions with working with these, or 9 or something like that, and then you have a couple, the same amount of questions working with these. So you can either work them out separately, doing this step, or you can go back to these functions if you feel you did these correctly, and working them out that way. But if you do it this way and then check it with this, that will make sure you did it the right way. So have a wonderful summer. I may send you another message just to say thank you for all your work this year. I enjoyed your class, enjoyed getting to know each one of you. I see you through middle school usually growing up, but I don't get to know you very well until I actually have you in class. So have a good summer. I'll see you next year. Best wishes. All of you should be going into geometry. I think you'll have Mr. Hebert for that. And so yeah, if you have anything you ever need from me, please let me know. I'm here for you. I want to support you in and out of the classroom. So I will talk to you later. Miss you all. Bye-bye.